Imagine boarding a craft in Florida and arriving in China or even Australia in under an hour. While that alone feels futuristic, what if we could go far beyond Earth, in fact, to the stars themselves? At the University of Central Florida, researchers are advancing hypersonic technology to make high-speed travel safer. But far more groundbreaking is NASA's recent revelation: a conceptual engine that could theoretically achieve faster than light travel. For decades, this has been confined to science fiction. Now, with new theoretical frameworks, it's becoming a subject of serious research and engineering. The challenge of distance. The greatest hurdle in space exploration is distance. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. With today's fastest spacecraft, such as the Parker Solar Probe moving at 430,000 miles per hour, the journey would take over 6,000 years. Clearly, something revolutionary is required, something far beyond chemical propulsion. Traditional rockets burn fuel to produce thrust, but they are severely limited by energy density and fuel mass. To even reach a fraction of light speed, current technology would require impractically massive fuel loads. The new approach: propulsion without propellant. NASA's breakthrough pivots away from fuel-based propulsion. Instead, it uses principles from theoretical physics to manipulate space itself. This idea is rooted in Einstein's general relativity, which describes how space and time can be bent and warped. This is the concept behind a warp drive not by moving the spacecraft through space, but by compressing the space in front of it and expanding the space behind, allowing the vessel to ride a wave of warped spacetime. Inspired by the Alcubierre drive in 1994, physicist Miguel Alcubierre theorized this concept, though it required an exotic form of matter with negative energy something yet to be observed. However, scientists at NASA's EagleWorks lab, led by Dr. Harold White, have been exploring phenomena like the Casimir effect where two plates placed close in a vacuum exhibit measurable negative energy density. If scaled, this effect could theoretically generate a warp bubble. Quantum vacuum and exotic energy. Further research explores the quantum vacuum, the so-called empty space, actually filled with energy fluctuations. By manipulating these, there's hope of creating the exotic conditions required for warp mechanics. At the same time, electromagnetic propulsion systems using plasma such as the Vasmer engine demonstrate how we can generate thrust without burning fuel. Though not capable of light-speed travel, these systems inform future designs. Powering the future. Antimatter and fusion. A key challenge remains: energy. To warp spacetime, a ship would need energy equivalent to a star. This is where antimatter comes in. When matter and antimatter collide, they release vast energy, making it an ideal power source, if it can be produced and stored safely. NASA and global partners are now investigating containment strategies using magnetic fields to trap antimatter. Fusion energy the same that powers our sun, is another viable long-term option. Computational power. Quantum computing. Controlling a warp bubble and navigating space at such speeds requires processing unimaginable amounts of data in real time. That's where quantum computing becomes vital. These advanced computers can handle complex calculations that traditional systems cannot, enabling autonomous decision-making and safe warp travel. What it all means for humanity. Successful, this engine could take us to distant stars within a human lifetime. Missions to nearby exoplanets, previously deemed fantasy, could become a reality. This could lead to new homes for humanity, addressing challenges like overpopulation or planetary threats. Just like the Apollo missions united the world, the pursuit of interstellar travel could ignite a new wave of global cooperation and innovation. But this journey will be long and filled with engineering, ethical, and environmental challenges. Closing thoughts. NASA's light speed concept isn't just about reaching new planets. It's about redefining what it means to explore, to survive, and to thrive. As we stand on the edge of this extraordinary frontier, we're reminded, somewhere, something incredible is waiting to be known. With new science, new dreams, and renewed ambition, we may one day look back at this moment as the start of humanity's journey to the stars. The era of interstellar exploration is not just about science. It will also deeply reshape culture, economies, and global politics. Entirely new industries may emerge around the design, construction, and operation of interstellar spacecraft. These developments will not only drive job creation and technological innovation but also shift the balance of power among nations. Countries and organizations will both compete and collaborate in their efforts to establish a presence beyond Earth. But great power brings great responsibility. The capability to travel to other star systems comes with a moral imperative. Questions arise. How should we approach alien ecosystems? What if we find life? Our current planetary protection protocols will need to expand far beyond Mars or Europa. Preventing biological contamination will be crucial, both to protect other planets and to preserve their scientific integrity. This new phase of space exploration could also serve as a unifying force. No single nation can achieve interstellar travel alone. The challenges are simply too great. International cooperation will be essential, fostering the spirit of shared purpose. In a more speculative future, humanity could even collaborate with intelligent alien civilizations, if any are found, to share knowledge and explore the universe together. Looking forward, NASA's conceptual light-speed engine stands as more than a technical achievement. It symbolizes a leap in human potential. Interstellar travel could reshape our understanding of life, reality, and our place in the universe. Discovering alien life or new habitable worlds could address existential threats like climate change and resource depletion by giving humanity new homes. While daunting, the journey is worth it. As Carl Sagan said, "We are a way for the universe to know itself." A light-speed engine could be humanity's first step toward fulfilling that cosmic destiny. The ability to travel at or beyond light speed could redefine how humanity functions. In the past, every transportation breakthrough, from the wheel to the airplane, reshaped societies. A light-speed engine would represent a quantum leap in how we view borders, resources, and civilization itself. Imagine access to asteroids, moons, or exoplanets rich in rare minerals, ice, or clean energy sources. This abundance might solve global issues like poverty or inequality. But it could also spark conflict. Who governs these resources? Would a new space race emerge, repeating the colonial mistakes of Earth's past? Culturally, our worldview would expand. Religion, philosophy, and art would evolve to reflect humanity's broader cosmic understanding. Finding intelligent or microbial life could challenge or reaffirm deeply held beliefs. Artistic expression, literature, and media would adapt to capture the vastness and wonder of space. Economically, the impact is incalculable. Like the internet before it, interstellar travel could birth new industries. Resource extraction from other planets could alter the global economy. Interstellar tourism might become a luxury market and later, a norm. However, economic disparity could widen if access to these technologies remains restricted to wealthy nations or individuals. The ethical questions are just as complex. How do we prevent harming alien ecosystems? Should we even colonize planets that seem empty? Humanity's record on Earth, marked by exploitation and environmental harm, demands caution. First contact with intelligent life would pose deep moral and diplomatic challenges. Who speaks for Earth? Should we even reveal ourselves to potentially advanced alien civilizations? Colonization also requires new ethical frameworks. If we settle a habitable planet, how do we ensure it's done sustainably and equitably? History warns us of conquest and inequality. We must avoid those pitfalls by creating new principles of space governance that respect the intrinsic value of other worlds. NASA's light-speed engine remains theoretical but promising. Turning it into reality will take decades. Initial steps include experimental validation, prototype development, and solving immense engineering problems. Power sources, like antimatter or fusion, must become viable. Materials capable of withstanding high-energy travel must be developed. International partnerships will be essential. NASA is already collaborating with other space agencies, universities, and private industries. Global cooperation will ensure that the benefits of space travel are shared, not monopolized. Public engagement will also be crucial. To gain support and inspire future scientists and engineers, NASA must foster public understanding and enthusiasm. Educational programs and transparency will help build the cultural momentum needed to sustain such long-term efforts. Once operational, the light-speed engine opens doors to extraordinary missions. First would be robotic exploration of promising exoplanets like those in the Proxima Centauri or TRAPPIST-1 systems. Finding life, even microbes, would be a monumental discovery. Next might come interstellar colonization. Generation ships carrying humans and infrastructure could establish self-sustaining colonies on habitable planets. Terraforming may also be considered, though it raises ethical and technical questions. Finally, missions to explore black holes, neutron stars, and other extreme cosmic phenomena could redefine physics. These missions might even lead to breakthroughs in energy, AI, and quantum computing. The vision is clear. Interstellar travel will challenge, unite, and elevate humanity. NASA's engine, still in its infancy, represents our first real shot at the stars. The journey has already begun.